Let's start with the question number 14. A city has two main roads which cross each other at the center of the city. These two roads are along the north-south direction and east-west direction. All other streets of the city run parallel to these roads, which are 200 meters apart. These are 10 streets. There are 10 streets in each direction. So a city has two main roads which cross each other at the center of the city. And these roads are along the north-south direction. North-south direction, this is north-south direction, correct? And so one road is along with the north-south direction, another road is along with the west-east direction. So it's look like a coordinate axis, x and y axis. So we can compare the diagram with the x axis, y axis. All other streets of the city run parallel to these roads and are 200 meters apart. There are 10 streets in each direction. So we have directions, 4 directions. So we have to concentrate in one direction, it's enough. Now the first question is, using 1 centimeter equal to 200 meter, draw a model of city in your notebook. Represent the roads and streets by single lines. Now this is the graph. We drawn the graph. So this is west east direction road. This is south north direction street. Now these two streets intersect at some point. That is the center of the city. So this is the center of the city. Okay. So in the given question, we have to make a model for the given information. So a city has two main roads. Yes, this is one main road and this is another main road. So these two main roads intersect at the center of the city. These two roads are along the north-south direction. Yes, one is north-south direction. Another one is west-east direction. And all other streets of the city run parallel to these roads. Yeah, we can form streets which are parallel to these two roads. So we can form 10 streets, and each and every street's distance is 200 meter. So 1 centimeter equal to 200 meter. So we draw the diagram for the first question. And the second question is, there are streets intersection in the model. Each street intersection is formed by two streets, one running in the north-south direction, another running in the east-west direction. Each street intersection is referred to in the following manner. If the second street running in the north-south direction and the fifth street in the east-west direction meet at some crossing, then we call it as street intersection 2, 5. Using this convention, find how many street intersection can be referred to as 4, 3. How many street intersection can be referred to as 3, 4. So in our question, 2, 5 is a street intersection. 2, 5. So 2 running in the direction of north to south. So this is second street running in the north-south direction, and the fifth street in the direction of east and west. This is the fifth street. So intersection of these two is, this is the cross section of these two streets. So this point we can represent as 2, 5. It's mentioned in the question. This point represent in the coordinate of 2, 5. This is given in the question. Now the question is, how many street intersection can be referred to as 4, 3. So similarly we can find the cross section of 4, 3. So 4, 3, this is 4, 3, and similarly 3, 4, this is 3, 4. So 4, 3 represents one street intersection of two streets. 3, 4 intersection of two streets. Question is, how many street intersection can be referred to as 4, 3? So we have only one street intersection can be referred to as 4, 3. Similarly, we have only one intersection can be referred to as 3, 4. This is the answer for the second subdivision. Next question number 15. A computer graphics program displays image on a rectangular screen whose coordinate system has the origin at the bottom left corner. The screen is 800 pixels wide and 600 pixels height. A circular icon of radius 80 pixels is drawn with the center at the point A 100, 150. Another circular icon of radius 100 pixels is drawn with center at the point B 250, 230. Determine whether any part of either circle lies outside the screen and whether the two circles intersect each other. Now let's see the diagram. See the diagram. This is the diagram of the given question. So this is a computer graphics screen which displays the image rectangular screen. This is 800 pixels wide and 600 pixels 800 pixels wide, 600 pixel height. A circular icon of radius 80 pixels which is drawn at the center point A 100, 150. So this is 100, 150 point A. This is center. By using the center, we draw the radius with 80 pixels. At this point A, consider a center point, we can draw the circle with the radius 80 pixels. Similarly, we can draw the circle at the center 250, 230. So this is 250, 230 point B. By using the point B as center, we can draw another circle with the 100 pixel radius. Now the first question is whether any part of either circle lies outside the screen. No, because both the circles lie inside the screen. This is the screen. This is the screen. So both the circles lie inside the screen. That is the answer. And next one, whether the two circles intersect each other. Yes, two circles intersect each other at two different points. This is the answer for the 15th question. Now we are going to complete the chapter. This is the last problem of this chapter. Problem number 16. Plot the points A 2, 1, B minus 1, 2, C minus 2, minus 1 and D 1, minus 2 in the coordinate plane. So we have to plot the points in the coordinate plane. The first coordinate is A coordinate is 2, 1. So right side 2, up side 1. This is A 2, 1. Then coordinate B minus 1, 2. So minus 1, 2. This is the point B minus 1, 2. Next point C minus 2, minus 1. So this is a point C minus 2, minus 1. Then the point D 1, minus 2. So this is 1, minus 2. Point D 1, minus 2. We plot the 4 points given points in the coordinates plane. Now we can join these 4 coordinates. Now we join these 4 coordinates. So the next question is ABCD is a square. So the diagram, from the diagram, we have to find out ABCD is a square or not. Can you explain why? What is the area of the square? So we have to find out these 4 coordinates forms a square or not, and then we have to explain why. Then what is the area of the square? So in this graph it look like a square only, but from the graph we cannot conclude the answer. So we have to conclude the answer by using the distance formula. So we know the properties of the square. In square, all 4 sides are equal and also diagonals are equal. Because if all 4 sides are equal, if you check all 4 sides are equal or not, after completion of the checking, if all 4 sides are equal, don't conclude it is a square. Because if all 4 sides are equal in the quadrilateral, it may be a square or rhombus. Okay, so by using the sides only we cannot conclude the answer, the square or rhombus. Okay, so we need additional information about the diagonals also. So by using diagonals we can conclude it's a square or rhombus. So first find the distance of all 4 sides and also 2 diagonals. Now we can find the distance of AB first. We found the distance of AB. The distance of AB is square root of 10. Similarly, we can find the distance of BC, CD, AD, AC and BD. We found the distance of all the 4 sides. So all the 4 sides are equal to square root of 10. So these 4 are sides of ABCD. And AC, we found AC and BD also. These 2 are length of the diagonals also. So all 4 sides are equal and diagonals are also equal. So we can conclude that it is a square. So far we completed the chapter 1, all exercise problems. I hope really you understand all the concepts of the first chapter. If you need the second chapter solution, then please comment. Then I will post the second chapter solutions also. Thank you.